In this video, I want to show you how to solve the typical problems that classic methods call the direct simple rule of 3. But before anything else, I want to point out to you that those two theories, on which the classic methods of direct or inverse relationships between magnitudes are based, are not correct. In fact, they are merely theories that have not been proven, and the classic methods have not been proven either. So much so that, in fact, inverse magnitudes do not exist. The method I propose is based on the First Algebra of Magnitudes. It has been approved by double peer review, meaning it has been approved by the scientific community as a whole on 2 separate occasions, once in English and once in Spanish. I'll leave a link in the description so you can access both versions. They contain exactly the same content, but they are very important because that's where I demonstrate that this method I propose. It is applicable to any type of exercise. But let's get to the matter at hand, which is that I'm going to show you how this method is applied to a specific case, which is as follows. If 2 pounds of potatoes cost $0.80 and Anna buys 5 pounds of potatoes, how much will she have to pay? First of all, what we need to do is distinguish what the statement of the question is. What is the statement in this problem? It's the part of the problem where there is no unknown, that is, we know all the data. What information do we have here? 2 pounds of potatoes and then their price, which is $0 to $80. So that is the statement. If 2 pounds of potatoes cost $0.80, what do we have to do once we've identified the statement? We have to distinguish which quantities are resources and which quantity is work. And from there, obtain that proportion within the statement. So within the statement, if 2 pounds of potatoes cost $0 to $80, which of those 2 quantities we've identified is the resource? Well, the money. That is $0.80, and we write it with the corresponding unit, dollars, which is the currency in which this is being measured, measurement. And this here equals the final work, that is, what do we get with that money? Well, we get the 2 pounds of potatoes. 2 pounds. Alright, now let's move on to the part of the question where we actually find the unknown we want to figure out. And it says, Anna buys 5 pounds of potatoes. How much will she have to pay? Well, we know what the work is in this case, which is the 5 pounds of potatoes. So we know the work part of the question. What we don't know is the resource, which is how much she will have to pay. We know what currency she's paying in, which is the dollar. So we know the dimensional element of this measurement, or the magnitude. What we don't know is the amount of this magnitude, which is the dimensional element, and we represent it with an x. Alright, so now we have the proportion for the question and the proportion for the statement. The only thing left is to calculate the proportion for the entire problem. How do we do that? If we divide both sides of the two equalities term by term, we get a single equality from which we obtain the final proportion. Since we're dealing with the First Algebra of Magnitudes, because we're working with magnitudes and not just arithmetically, we need to distinguish this division with magnitudes, following the rules of the First Algebra of Magnitudes, using 2 horizontal lines. So what do we have? Well, we have the final proportion, $0.80 over x dollars is equal to 2 pounds over 5 pounds. What happens from here? It's very simple. The First Algebra of Magnitudes has shown that when a magnitude is divided by itself, you get an abstract number, which is 1. What do we have here? Well, on the first side of the equation, we have dollars divided by dollars, which gives us the abstract number 1. And on the second side of the equation, we have pounds divided by pounds, which also gives 1. So what do we have in the end? A simple arithmetic proportion. 0.80 over x equals 2 over 5, and all that's left from here is to solve for x. So what is x equal to? Well, it's equal to 0.80 times 5 divided by 2. So what do we get then? We get that x equals 2. Going back to the original measure, which was x dollars, we're talking about $2 being the cost to buy 5 pounds of potatoes. And it's that simple. If you want me to solve a specific problem, leave it in the comments. And what I do ask of you, please, is to help me make this method known. Thank you very much.